back, students. So we will continue from where we have left yesterday, that is the ECG, the conductive system of heart, how we measure the conductivity of the heart. We measure the conductivity of heart through the ECG. So an electrocardiograph is an instrument which helps to measure that conductivity. That conductivity of the heart is actually the electrical impulses being produced by the conductive system of the heart, and the electrocardiograph is a machine which records those electrical currents by determining the passages of the waves through different nodes, that is AV node, SA node, etc. And if the graph is not comes out to be an as usual a normal graph, that means that your heart is working in abnormal condition. So this is a typical readout of the ECG, and this is what the graph is going to trace out. There are some waves, there are some segments, and there are some intervals. So the first is the P wave, then the T wave, and then there is the QRS complex. We will study about this like this. So components of the ECG includes, number one is the wave. So there is P wave, which act as an atrial depolarization indicator. Then comes the QRS complex, which is the ventricular depolarization indicator, and then comes the T wave, which is the ventricular repolarization indicator. Then there are segments. So what is a segment? It is a straight line between the waves. So there is one segment called ST segment. So it is the end of a ventricular depolarization and start of the ventricular repolarization. Okay. So last one is the intervals. Intervals are the addition of the waves and segments. So there are only two intervals in between, that is the P to R interval, that is PQR interval, and Q to T interval, that is QRS and T interval. So, what is the basic principle of ECG and its recording? So, waves of depolarization, when they moves toward the positive electrodes, they show an upward deflection on the ECG. And when the wave of depolarization travels away from the positive electrode, they show a downward deflection on the ECG. This is what we study on the ECG. So how we study that? So first is the P wave. P wave mean the depolarization of both the atria. That means there will be the upward deflection. So first upward deflection, which will be of 0.1 second duration, and it will be followed by the QRS complex, and shape and duration of P indicates that there will be some atrial enlargements. Okay, you can see it in the diagram. Then comes the PR interval. So from the start of the PA to the start of the QRS complex. So this is called the PR interval, which ranges from 0.12 to 2 seconds, and it represents that there is atrial to ventricular conduction time, that is the time or the passage of the wave up to the bundle of His. So if there is prolonged PR interval, that is more than 2 seconds, that indicates that there is first degree of heart attack. Then comes the QRS complex. So this is the area where you can see the ventricular depolarization. Again, this is the ventricular depolarization. That means the wave will again deflect upwards. So this is the larger wave than the P wave, because the muscles of the ventricles are having more mass, muscular mass, than the P wave. So normal duration ranges about 0.08 to 0.12 seconds, and it includes three waves, that is Q, R, and S wave. So Q wave means the negative deflection after the P wave. So here it is a negative deflection. That is, the charge is moving away from the positive charge. So the deflection will go downwards. And this depolarization is happening at the point of septum. And it cannot be seen always on the graph. Then comes the R wave, which is the first wave after the Q, or you can say this is the first wave after the Q which is having the positive depolarization. That is, the wave is moving again upward. But after that, there comes S wave again. That is, again the wave is going to be deflected downwards. Then comes a joint that is called J point, sorry. So this is the point where QRS complex returns to an isoelectric line. Isoelectric line is the straight line. Again, it comes upward and it remains on the specific line. So from here, the ST segment is going to start. So the what is the ST segment? It is the early repolarization of the ventricles so that the T wave can takes place. Repolarization of ventricle, that means they are going to again relaxed. Okay. So the T wave, which represents the repolarization or recovery of ventricles after taking up the blood from the atriums. Once the ventricles have received, they have forwarded again forward to the body parts. Now it again becomes relaxed. So this is the interval from beginning of QRS to the T, and this is called absolute refractory period. And then comes the QT interval. This is measured from the beginning of the QRS to the end of the T wave. Okay, so this is normally known as the QT, and it is of 0.40 second interval, but it varies based upon your heart rate. If your heart rate is high, it can be different, and if your heart rate is slow, it can be different. Okay, so this is how your ECG formation takes place. First is the P wave, and then again comes the other areas like P wave, the QRS complex, and then the T wave, and all the segments and intervals. And finally, you can see in the last image, that is what the ECG formation in actual. So thank you. I think you have learned a lot from this PPT. We will meet again tomorrow. Thank you.